Yo, what's going on? I hope you're doing well. We're here with the last new, the last new problem set. Um, and I got to be honest, it's going to be kind of anticlimactic because I think this lesson's dumb. Let me just put that on the top. I mean, it's not dumb, but I told you already. Like, this is my first time teaching chi squared, and basically, there's three types of chi squared tests. I'm just going to get right into it, and then whatever. There's the goodness of fit, which we did last week. There's the independence, which we did the first problem set this week. And then there's this third one called the test for homogeneity. And the problem with this, the reason I think it's dumb, is that researching this and all of that, I've come to the conclusion that this is the exact same thing as a test for independence. Okay, like it's so similar that I don't know why they have two names for them. That's what confuses me. And they're not the exact same. And we'll talk about the only difference, which is the hypotheses. But that to me doesn't like warrant the fact that we have like a third different name. Okay. So like sorry if I'm being confusing, but just think like there's really only two types of goodness of fit crap. There's only two types of chi squared. You either have a single row, or you have a full two-way table. And either way, you're comparing the values that were given, the values that were observed, with what you would expect to happen. Okay. And what I mean by expect is if all of your countries or whatever you're talking about have the same proportion or the same percent. Okay. So, yeah, basically today is going to be super similar to the last lesson, which I think is going to make it pretty easy. Um, and then the second thing to talk about is after this, we're not done. We have 3.5 weeks till the AP exam, and I've all but decided what we're gonna do at this point. And it's not go optionally live. I just kind of don't see the point of that when we don't have a culture for it, and students have scheduled themselves not to be live for this class. So I think it'd be much more effective for the students who are really with it to sign up for office hours. And you can sign up with your friends. You can, if you already do that, that's good. Um, and you can ask me questions if you would like, and I think that that's going to be a lot better. But I think the plan, like, let me just tell you the plan before I really tell the plan to everyone. But I think we're just going to do like 4 practice tests, a practice test every week before the exam, each one having a slightly different topic. So I'm actually going to decide, I think we're going to go backwards. So next week, we'll do a practice test that's all about inference. So like 40 multiple choice, 6 free response, all about inference. And then we'll kind of work our way back to the beginning of the year. Um, and then the only assignments you'll have is to complete all the practice tests. And I think I'll do 2 videos a week, one multiple choice, one free response. And then last year I had a bunch of videos for free response because that was the whole AP exam. And I'm not going to try to rewrite the wheel. So I'm going to use those videos as extra support. So yeah, that's kind of my whole plan, but I might change that by next week. But anyway, I think we're in good shape. Sorry, I talked about the lesson, then about the AP, and now about the lesson again. Sue me. Okay, let me just read this question. Let's get into it. It says that a researcher wants to know if attitudes towards vaccines are significantly different between different countries. In 3 random samples taken in the US, the UK, and Italy, people were asked if they plan on getting the vaccine when it is available to them. The samples are recorded in a two-way table below. And what we're trying to do is we're running a chi-square test for homogeneity to see if there's a difference between the 3 countries. So let me see. If we're looking at these two questions, so this is what we did last time, these two-way tables look nearly identical to me in their concept, right? Multiple groups being tested over some sort of question. And that's because it is the same thing. What distinguishes a test of homogeneity is that the samples that you take are supposed to be like independent of each other and separately done. Okay, and I know that sounds really weird, but think that for the last one, you have two different categories that you ask a bunch of people, and you want to see if there's a difference between those two categories. Okay, so think that this was a survey given to all WCCUSD, and you ask them their age and whether they approve or disapprove, and you want to find if there's independence between them or an association. Here, think that each of these tests was done individually. So think that someone, some American took an American survey, some UK person, or British person, I guess, took a survey of British people, etc. So think of these as three separate samples, and we want to see if this is evidence that those three samples are significantly different. Okay, so it's going to be the exact same thing, but in our null and alternative hypothesis, all we're saying is that there's a difference between the three countries for the null, and we're trying to prove that, or sorry, there's no difference between them, but we're trying to prove that there is a difference. So the only thing that changes, even though it looks the exact same, is for a test of independence, your hypotheses are they're independent and they're non-independent. For homogeneity, it's going to say three different random samples or something like that, if you even see this. And you want to find, is there a difference between them? And like, maybe you're like, this is dumb. And that's why I put dumb on the top. And I promise you, it's not like I'm confused. Like, there's really not really much of a difference between these two types of samples, or sorry, these two chi-square tests. So if you're asked to conduct either of them, just think the exact same thing, okay? So there's no difference between the samples. And then for the alternative, there is a difference, okay? And the math is going to be the exact same, where we're going to take every section and compare it to what's expected, and then find a chi-squared. And if that chi-squared value is really big, that means there's a significant difference between them, and we're going to reject that there's no difference. So now let's get into the math itself, which is what I think is the most important. What we learned last time was really powerful, is that if these values are independent, the way that we can find what's expected is just by multiplying the row and column totals and dividing by the total. So I can do this for each of my values, and you'll know you're on the right track because it's like reasonably close to the number you see. But basically, if all of these are equal to each other, we would expect 121 people in the US to get the COVID vaccine. And then 28.5 would not. So more than expected are not going to get the COVID in the US. And we're going to do this for each of my values. And this is the way I think is the easiest to do this. Like, rather than create a second table, you can put all of your expected values in parentheses. This one should be the same as the first one because you're multiplying the same values together. So let's just confirm, but I think it should be 28. Cool. Okay. So yeah, this is actually just going to be pretty tedious. So maybe this will be a quick little video, but I'm going to take each of these values and subtract away the expected, square it, and divide by expected. Okay, so I'm getting a chi-squared of 11.31, and then the degrees of freedom is the number of rows minus 1 times the number of columns minus 1, or the other way. I don't know. what a row or column is, I forget all the time. But yeah, the degrees of freedom is 2. And, it's good to always kind of know what to expect in a math class when you're doing math so that if something's way off, you know. But a double digit is going to usually indicate a small p-value. So the degrees of freedom was 2, and we are at 11.31. Degrees of freedom are 2 a lot for a chi-squared. But here we are, and the p-value is really close to 0.25% or 0.0025. But we'll say the entire range. And we'll say this is a 5% test, but that's way less than 0.05. Okay, so think that the values here were significantly different than what you'd expect. Mostly like these values are going to kind of crush it, because just to talk about it, like one thing I noticed is the expected value plays a big role in the number, right? So these small values that were pretty off really kind of make this happen. So this is my p-value, which means that there's a really small percent chance that there's no difference. So we're going to reject that there's no difference and say that we are in favor of the alternative that there is a difference. So we'll reject the HO in favor of HA. So yeah, I think that went super, super quick, which is fine with me. Our last lesson of the year, mostly we're just kind of practicing chi-squared again. And yeah, there's 2 different words for the same test, the independence and the homogeneity. So make sure, like, if this did happen on the AP or whatever, that your hypotheses kind of match which one you're doing. But the big thing to know here is that you can compare multiple samples from different places, from different populations, and test the difference between them using this test. Alrighty, so we'll be back next week with videos for sure, but you've learned statistics. So yeah, woo, proud of you, appreciate you.